Okay, so this is the first day of Honors Algebra 2. You should have a packet that looks like this. You will be physically receiving it in class. So if this is your first day and you're at home, there should be a PDF file for the entire set of notes. Or you can just wait to grab them, either one, but these are the notes to complete the homework. So on the first page, it's just a review of Algebra 1. I unfortunately recorded this already with Screencastify, but the quality of the sound was atrocious, so I'm just going to do it again and point to the words that I filled out. So it says label the following using the proper terminology. These numbers here in this equation are called constants. This is the variable in the equation, and there's a coefficient that's always in front of the variable. These two pieces on either side of the equation are called expressions. And the entire thing is called an equation because it has an equal sign. Ignore that for the moment. Next, we're going to review properties from Algebra 1. If x equals 3, then 3 equals x. That is the symmetric property. If I have to divide 2 from both sides to get x equals 3, then this was the division property of equality. It says what I do to one side, and if I divide by the same thing on the other, then the equation will still be equal or equivalent. I had to add 5 to both sides to create this next line, so that's the addition property of equality. I subtracted 2x from both sides, so that's using the subtraction property of equality. And if this first thing equals the second thing, and the second thing equals this third thing, then I substituted. So you could say substitution property, or when there's 3 things involved, that's a key to say, okay, that's the transitive property. To get rid of 2/3, I use division, but I've already used that. So you could say division property, or you could say multiplication property of equality. Either one. And those are from honors geometry. So it's just a little review here. Associative property, we say that when I see parentheses, it's like associating between 2 different groups. If I add this group first and then add C versus adding the last group and then adding A, it makes no difference. Commutative, A plus B is the same thing as B plus A. Distributive, that's our familiar, that's our favorite. We're just distributing to each term inside the parentheses. And identity, it keeps its identity. So what can you add to A to keep A the same? Add an identity. So 0 is called the additive identity. How do you get from A to A by multiplication? You multiply by 1. So 1 is a multiplicative identity. Here, the inverse property inverts or undoes what's being done. So how do you get rid of an A by adding or subtracting? You remove what's there. So you get 0. And how do you remove A by multiplication? You multiply by its reciprocal. Okay, now we're going to classify numbers, real numbers. So a number is either rational or irrational if it's a real number. Your textbook calls them Q's or I's. That's fine, either one. Not all textbooks use this notation of N, W, Z, I, Q, so don't think you need to memorize it. It's just the textbook, how they classify. But a rational number is any number where P over Q, and where these are integers, works. So Q can't be 0. So for instance, 5. Well, because 5 is technically over 1. -6 over 4. You can reduce that. Well, yeah, that's an integer. That's an integer. Okay? As long as that bottom number is not 0. Now, why would this bottom number not be 0? Because you can't divide by 0. So let's talk about, middle school. What's 6 divided by 3? 2. Why? Because 2 times 3 is 6. So you're allowed to divide by 3. 10 divided by 2 is 5. Because 5 times 2 is 10. What's 5 divided by 0? Say you're in middle school, didn't know this property, you might say 5. Well, 5 times 0 is 0. Not 5, so that doesn't work. 5 divided by 0 is 0. Well, 0 times 0 is 0, not 5, so that doesn't work. So it breaks the definition of division, therefore it's undefined. Okay? So we have to make sure that Q is anything but 0 when we have a rational number. Other numbers are integers. Integers are negative and positive whole numbers. Whole numbers are the natural numbers with 0. Whole. Natural 1, 2, 3, 4. What would you naturally count to in mathematics? When you were like a baby, you would start with 1. You wouldn't start with 0. You'd start with 1. All right, on to the next page. We're starting to get a little more Algebra 2-like. Example 1, we're going to talk about solving equations. So example 1 is solving this equation. We have to free up this x to solve for x. Okay, it should say solve the equation for the variable x or solve for the variable. It's kind of vague in the directions. So here we're going to distribute 5x, 5 to x and 5 to 4, and we're going to get 3x minus 8 equals 5x minus 20. I like to deal with the x values first. It makes things simpler as we get to harder problems. Subtract 5x from both sides, you get negative 2x minus 8 equals negative 20, and then just divide by negative 2 and you get 6. So the beauty of math is that you can check your work. So when x equals 6, this equation should be true. It should be satisfied. It says when you solve an equation, you're looking for the value of the variable that makes the two expressions equal. These will be equal if x equals 6. Substitute your answer back in to make sure the value of x is correct. Do you have to do this every time? No. As you get better at these things, you don't have to check your work, but if it was a test, I would. Substitute 6 back in. As you break down, oh, 10 equals 10, that's true. My answer's correct. All right, solving more equations. We have, this one's a lot of fractions. We don't like fractions usually just because they're difficult to deal with. I'm going to encourage you to put this into an improper form, and we're going to use a method called clearing the denominator, which will make it easier. So if I'm going to put this in improper form, 7 times 4 is 28 plus the 3. It's going to be 31. So 31 over 4. Fractions are simply division. So I'm dividing by 4, I'm dividing by 3, and I'm dividing by 4. Okay, I don't want this division here. I want it gone. So how can I compensate for getting rid of this 4? By putting a 4 everywhere else. We'll keep it balanced. So I can multiply the whole thing by 4. How could we get rid of dividing by 3? Multiply everything by 3. You can just do that with equations. You can just multiply or divide or add or subtract as long as you're doing it to both sides. So here, what number is going to multiply everything by 4 and multiply everything by 3? The number 12. So we're just going to use 12 to wipe everything clear. So 12 times x is 12x. 12 times a fourth is 12 over 4. 12 times x over 3 is 12x over 3, and 12 times 31 over 4. So we get 12x, we get 3, we get 4x, and 12 over 4 reduces to a 3. 3 times 31 is 93. If you need to pause at any time during these videos and go back, feel free to. Now let's deal with the x's first. Subtract 4x from both sides, add 3 to both sides, and divide, you get 12. Now, I want you to pause the video at this point and you complete the try. Try it on your own without looking, and then come back to the video and see if you did it right. Okay. We are over 8, we are over 1, and we are over 4. We're dividing everything by a number. What number contains 8, 1, and 4? The number 8. We call this our least common multiple. We could have multiplied everything by 40, but 8's the smallest number that would contain all of these things, and I could remove the denominators. So 8 times 3 is 3 times 8. 8 times 4 is 32, but I'm just leaving it like this for now so you can see. 8 times 1 is 8. This will be 24 over 8, which reduces to a 3. 32 over 1, which is 32, and 8 divided by 4, which is negative 2. There's actually a little negative there. That's why it's extended long. You might not be able to see the space. Well, I'm going to add 32 to the other side and divide, and A should be 10. All right, so that's working with fractions. We're probably going to have a worksheet where we really hit this home one day, okay? But mostly, that was all review. So your lesson for today is that you are going to solve literal equations by isolating variables, okay? You're going to solve literal equations by isolating variables. So a literal equation is an equation that contains 2 or more variables. So if you look at this Fahrenheit and Celsius, okay, equation, this is the literal equation that relates Fahrenheit and Celsius temperatures. So if I have a Celsius temperature, I can easily figure out what Fahrenheit is. However, if I have a Fahrenheit temperature, I have to do all the solving to figure out the Celsius. I want to create just a Celsius equals equation so that when we are given Fahrenheit, we know Celsius. So what you're doing is just strictly solving for C or isolating C. So you got to look at C. What is blocking C from being by itself? 9/5 and 32. How do you remove 32? Subtract it. Okay, so when you subtract it, you just bring it to the other side. And then you get this first line. F minus 32 equals 9/5 C. Now, how do you remove 9/5? Multiply it to the other side. You can divide both sides by 9/5 or multiply by the reciprocal, but I'm multiplying this entire quantity by 5/9. Now I want C to be first, so C equals 5/9 F minus 32. You're done, okay? Example 4, A equals V minus V sub 0. I say sub because it's a subscript over T. Probably A is acceleration, T is time, and V is velocity, and V sub 0 represents initial velocity. But here's the thing, you don't have to know any of these variables and what they mean. All the equation is asking is for V sub 0 to be by itself. So you got to look at the equation and see that T is by itself, or not by itself, it's blocking V sub 0. V is blocking V sub 0, and this negative is blocking V sub 0. So what do you have to remove first? This T. How do you remove the division of T? Multiply both sides by T. You're going to get AT equals V minus V sub 0. So AT equals V minus V sub 0. Then you look again and say, okay, I need to get rid of this negative and this V. How do I get rid of this positive V? You look to see what's in front of V. Well, I subtract it. So AT minus V equals negative V sub 0. I won't all have usually this all written out, but it already was recorded, like I said, and got, it's not the quality I wanted it. It's going to be a year of trial and error. Anyway, V sub 0, I have to get rid of this negative, so I multiply negative on both sides. So I'm going to get negative AT, positive V sub 0. That's it. Off to the side, all these random symbols, I'm just saying, I was making an example earlier, you could just use emojis as the same thing. Nothing has to mean anything, but are you intelligent enough to say, I can isolate them? Right here, I made up one. I said pumpkin equals heart minus cowboy. Wait, start here. Anyway, we can do it when we're in class. Remind me if I don't do it. But I'm saying you can use emojis, and if I said, hey, what does pumpkin equal? You can do the same thing by isolating pumpkin, by getting rid of peace sign and getting rid of cowboy and getting pumpkin equals, okay? So that was just an example I had in the previous video, but it's too messy now. All right, on the back, I want you to try these 6 on your own. Don't look at them, okay? These 6 are like a checking for understanding. Do you understand what has happened? Okay, I want you to pause the video, and when you come back, I want you to look at the answers. Okay, so pause it. All right, welcome back. So let's talk about this. How do you get R by itself? Get rid of 2t. They're both being multiplied, so divide both. Bada bing. Here, how do you get W by itself? You have to remove L and W. They're both being multiplied. You have to divide both. Here, how do you solve for A? Well, look at A. There's quantities in the way, there's negatives in the way, and T sub 0 is in the way. Get rid of T sub 0 first because it's the furthest thing away. It's positive, so you subtract it. You're left with this negative and the Z minus C sub 0. The negative and the Z's are both being multiplied because they're smack dab beside A. When they're beside each other, that implies multiplication, so I must divide both sides by the same thing, and you can do it at the same time. Well, the two quantities are going to cancel on this side, and the negatives are going to cancel, so A is going to equal this quantity and distribute the negative down there. Now, if you put the negative with the top, that's fine too. Your answer might look a little different. Same idea, full credit. Here, how do I get H by itself? How do I remove this quantity? The quantity is right beside H. So if it's right beside H, it's being multiplied, therefore I have to divide it. These ones are more challenging. we have fractions going on. Y is technically over 1, so I'm just going to cross multiply to get everything on one level. So y times this quantity, 1 times this quantity. I'm going to distribute, well, we have u's on both places, and I'm trying to solve for u. So let's distribute and free that u. Sorry, it's a little loud in other rooms. Okay. Remove this u to this side and remove 2y to the other side. So first we're going to bring u over here to go with the other u. So we had to subtract. Now remove this 2y. So we brought that to the other side. Now u is stuck in both. So how do I remove it? Factor it out. How do I get y by itself? Divide. Which brings me to the next point. We didn't talk about it. So if you're like, wait, what did you do with that u? Well, it's stuck in both, so I have to remove it from both. So let's go back in the notes. We didn't get that last one. ax plus b equals cx plus d. Solve for this little equation, literal equation. All right, x is stuck in both. Let's get anything that's an x to one side, so bring cx over, and then anything that's not an x, move to the other side. So subtract b, so we have minus b. So we have ax minus cx, d minus b. We're going to divide both sides by this quantity now, and now we have our answer. So that's pretty much what we have to do there. If it's in both, we have to extract it from both. We only have one number because when you go back and distribute, it works, okay? So it's kind of like that. Now here, you can do this a few different ways. You could have distributed to begin with first and said, okay, I need to get rid of this p by subtracting, and then divide out these two. Been done. Or you'll get a similar answer, it'll look similar, and it is the same. Or some people said, okay, I have t inside here, remove p by division, then get rid of 1 by subtraction, and then divide by r. If you left it like this, it's technically right, but some people would have said, okay, you're dividing by r, so you're multiplying by 1 over r. I don't care either answer. If that was too fast, I'm trying to get this all under 20 minutes, it's just a lot of material, you can pause it, rewind it, go back. That's the beauty of these videos. Okay, I am fortunate this year where I used to want to do these all on video so students could have access to them, and now we're really dedicating the time to have these. So make sure you utilize them if you have confusion, okay? If there's still questions, we're gonna have a bell ringer on this when you come back, so we'll have more practice, okay?